So units and measurements is such an important topic in physics which will provide us a framework. A physical quantity is any property of matter or energy that can be measured and expressed as a number along with a unit. Physical quantities which are independently expressed by some units are called as fundamental quantities. Hello students, welcome to this session on units and measurements. Units and measurements is one of the foundation or basic modules of your first PUC physics. I am Madhu R, Department of Physics from Vidhyaashram PU College, your temple of excellence. To understand the basics of units and measurements, we will have to understand how evolution of mankind began. The evolution of mankind began by counting the things around him. What did the first human do? He began by counting the fruits around him, the animals around him. He counted how many apples were there. He probably counted what were the number of sheep in the herd, so on and so forth. What did he use to count the number of apples and the number of sheep in the herd? He used his fingers. So our fingers were the first tools that were used. You can also find the evidence of tally marks on bones which are dated back to almost 30,000 years. So the phenomenon of counting by humans was started at least 30,000 years back. Okay, but counting has got its own limitations. I can probably count the number of apples in a block, but I'll not be able to say which apple is larger, which apple is smaller. Obviously, as curiosity grew, and as the evolution of humankind began, started from counting, but then he moved towards comparing. He began to check which apple was larger, which stone was smaller, which tree was taller, etc., etc. So he wanted to understand, or he wanted to consume the bigger apple. He did not wanted that his share to be reduced. Further, with the evolution of humankind, he was not satisfied with this comparison mechanism. He could say that one apple was larger, the other was smaller, but he was not able to say which apple was the best one or which apple weighed the most. The mass of the apple was not known to him. So there began the enthusiasm. He wanted to measure things. He was not satisfied by merely counting or comparing. He wanted to measure. He wanted to measure how tall the tree was. He wanted to measure how heavy the apple was. What was the weight of an apple? And by that means that he evolved to understand what was the science of measurement, what we call today as the science of measurement. Before diving deep into physics, we have to understand what is measurement and what is the unit which helps us to replicate or which will help us to notate how we can denote the measured part. Okay, so units and measurements is such an important topic in physics which will provide us a framework so that all physical phenomenon can be told to people in a better way. Okay, so this units and measurements chapter is a framework. This is one of the foundation units which is required to understand physics in a better way. To understand units and measurements, let us first try to understand or define what is measurement. Okay, so what is measurement? Measurement is the process of comparing. What am I doing? I am once again comparing. In the previous slide, I told you that humans evolved from counting to comparing, comparing to measuring. Comparing. Here also we are comparing, but we are not comparing a smaller apple to a larger apple. We are comparing an unknown quantity to a standard quantity. I am comparing an unknown quantity to a standard quantity. What does this mean? Imagine you have to measure the length of a table. Okay, so the length of the table is initially the unknown quantity to me. But what am I comparing the length of the table with? I will use a standard meter scale. So that standard meter scale becomes the standard quantity. I am comparing the length of the table, which was the unknown quantity, to the meter scale. By that, I'll get the answer saying that the length of the table is probably about 2 meters. Okay, so measurement is the process of comparing an unknown quantity to a standard quantity. What can I measure? I can measure the length probably of a table of any object, or I can measure the distance between two objects. I can measure the mass or the weight. I can count the time. I can measure the time taken by one person to cover a distance of so many meters or kilometers, so on and so forth. But here you have to understand one more important part. I say that I am comparing an unknown quantity. So what is this quantity? What does quantity mean? Let us first try to understand what is a quantity, or rather what is a physical quantity. A physical quantity is any property of matter or energy that can be measured and expressed as a number along with a unit. In simpler words, if I have to say, physical quantity is anything that can be measured. Okay? Anything that can be measured can be called as a physical quantity. What are the things that can be measured? Now this plays an important role. I told you that anything that can be measured is a physical quantity. Now what are those things that can be measured? Let us take a few examples. I can measure the height of a person. I am calculating the length there. Okay? I can measure the weight of a person. I am calculating the mass. I can measure the temperature of an object or of a place with different units. So I can measure temperature. I can measure the time, probably of that of a sprinter who takes probably 9 or 10 or 11 seconds to cover a distance of 100 meters. I am measuring time. I can also measure how dark or how bright a room is. Can you see that? How dark or how bright a room is. This is called as luminous intensity. It is called as luminous intensity. So I can measure how bright or how dark a room is. These are few of the physical quantities that can be measured. Okay. Now when I say physical quantities are those which can be measured, are there some quantities which cannot be measured? Yes, obviously. That is why we said that they are called as physical quantities, and there are certain quantities which cannot be measured. What are those? Obviously, not all quantities are physical in nature. You cannot get hold of all the quantities. Some things are intangible in nature. Some things are intangible in nature, which means that they cannot be expressed in the form of a number. Okay? Those things which cannot be measured or which cannot be expressed in the form of a number are called as intangible. So, what are these intangible quantities? See, there are many such things which are intangible in nature. For example, your happiness. How happy you are today? I cannot say that I am 50 kgs happy today. Will be very absurd in nature. Okay? So, your happiness, the amount of love you can show, the beauty, kindness, thoughts, basically all the emotions of human beings are intangible in nature, which means that they cannot be measured. While studying measurement, it is very, very important for us to understand what can be measured and what cannot be measured. All those things which can be measured are called as physical quantities, and those things which cannot be measured are called as intangible things. Okay? Most of the emotions that a human has cannot be measured. Now, coming back to physical quantities can be classified into two types. What are those two types? Fundamental physical quantities and derived physical quantities. Two types. Okay? Fundamental as well as physical. What are fundamental physical quantities? Fundamental physical quantities are those which are independent of each other. Physical quantities which are independently expressed by some units are called as fundamental quantities. Yes, sir, example. What is the example? Length, mass, time, so on and so forth. It could be temperature, as I said previously, the intensity of light, luminous intensity, etc. Then what are derived quantities? Derived quantities are those physical quantities which can be expressed as a combination of the fundamental quantities. Those quantities which can be expressed as a combination of one or more physical fundamental quantities are called as derived quantities. So what is the example? I'll take the example of area. What is the unit of area? Meter square. So there are two physical quantities, length into length. It is a combination of two fundamental quantities. That is why it is called as a derived quantity. Similarly, volume, it is meter cube. Force is mass into acceleration. Similarly, momentum, velocity, speed, displacement, etc., etc., etc. can be calculated. Okay, so there are basically two types of physical quantities, the fundamental quantity and the derived quantity. Now, once I say that I am expressing the quantities as fundamental, derived, so on and so forth, I get a number which I have to express because I have measured certain things. Now, to express these measurements, I require a unit. I cannot say that I have brought 5 dash of milk today. It has to be in the terms of some units. I have to say 5 liters of milk today. 10 kgs of apple. I cannot just say I brought 10 apples today. That will be a count. If I have to measure, it has to be along with a unit. So what is this unit? Unit is an internationally accepted standard of reference. Please remember, it is an internationally accepted standard of reference. In the initial slides, I told you that whenever I am measuring, I am comparing an unknown to a standard. Okay, here also, it is an internationally accepted standard of reference which is used to express a physical quantity. Okay, please remember, it is internationally accepted and it is a standard of reference. Once again, units are also classified as fundamental units and derived units. The units which are used to represent the fundamental quantities are called as fundamental units, whereas the units which are used to express the derived quantities are called as derived units. Okay, the example for fundamental units: for length it is meter, for time it is second, for mass it is kilogram, so on and so forth. For temperature, you can take it as Kelvin. Similarly, derived units, see, it is Newton for force, meter per second for velocity, joules for energy, etc., etc. Okay, so what are units? Units are internationally accepted standards of reference. There are two types, the fundamental and the derived. Fundamental quantities are represented using fundamental units and derived quantities are expressed using derived units. Now, to understand the units in a better way, we have to go back and dig down and understand what were the types of units that were available to us over a period of time. Okay, majorly 3 units have been prevalent. If you just check your history books, what are those? The current system of SI units and previously used CGS and FPS units. So different systems were developed across time periods and across the world to standardize measurements. The FPS or the imperial system was where the foot of the king was taken to be the standard, and it was called as 1 foot measurement. It was divided into 12 parts and they were called as inches. Okay, so this was one of the standard that was available with us. Similarly, pound was used for measurement of mass and second was used for measurement of time. Okay, Fahrenheit was used for measurement of temperature. Similarly, there was a CGS unit where centimeter was majoritarily used for measuring length, gram for measuring mass, once again second for measuring time. Here, degree Celsius was adopted for measuring temperature. The latest SI unit is the internationally accepted one. Here, we are using kilogram for mass, seconds for time, and meter for length. You can use Kelvin for temperature, so on and so forth. So basically, to understand units, you have to understand that there were 3 systems that have been adopted worldwide. The initial one was the FPS system, foot pound second. Then there was the CGS system, centimeter gram second. And then there was the SI system, Système International d'Units. This was phrased in French because that conference was held in France. Okay, which means that units for international system. Okay, moving on. Let us check what are the 7 fundamental quantities, their units and symbols according to the SI, System International. Okay, according to the System International, 7 units have been denoted as fundamental quantities. What are those fundamental quantities? Length, mass, time, temperature, electric current, luminous intensity, and amount of substance. For length, meter was chosen to be the unit and M was the symbol. For mass, kilogram was chosen to be the unit and kg is the symbol. For time, second was chosen to be the unit and S was the symbol. Similarly, Kelvin for temperature, ampere for electric current, candela for luminous intensity, and mole for amount of substance. This candela is the amount of light that is given by one standard wax candle. Okay. Similarly, if you are wondering what is this amount of substance and mole, say I could count things until they were limited in number. I can count the number of fingers, I can count the number of students in a class, so on and so forth. If you ask me to count the number of hairs on my head, probably I'll find it difficult. So what did I do? I'll probably take a heap of hair, put it on a measuring scale and weigh it. Then say that 1 gram of hair will be so many hairs, something like that. Similarly, this amount of substance is used to calculate the number of atomic or subatomic particles in 1 kg of some substance. Okay, you will learn much about these things in your chemistry classes. Moving on, apart from these fundamental as well as derived quantities, you had something called as a supplementary. Okay, so you have got a supplementary unit. We have some fundamental units, we have some derived units. There is a certain quantity which cannot be expressed in both these terms, and that is a supplementary quantity, which is the angle. I cannot express angle either from the fundamental units or from the derived units. So what did we do? We used a different terminology, okay, to represent these angles. There are 2 types of angles basically. One is the plane angle, which you can find on a circle or a 2-dimensional sketch. You can represent that with theta. Okay, so theta or the plane angle is given an unit called as radian with the symbol rad. For the maximum angle inside a circle, theta will be 360 degree. Yes, you know that. The maximum angle in a circle will be 360 degree, and that is denoted by 2 pi radians or 2 pi rad. This will be helpful somewhere else. Okay, please, you can make a note of it. Similarly, solid angle denoted by omega. Okay, this is given by 4 pi and the unit is steradians. Symbol is SR. Okay, we could not express the quantity angle either with the fundamental units or with the derived units. So we took the help of supplementary units. Plane angle can be expressed with the help of a unit called as a radian. solid angle which is inside a sphere, okay, can be represented with the help of a unit called as steradian. The symbol is rad for radian, SR for steradian. Okay, so we had fundamental units, derived units and supplementary units. Now we said that there are three systems across time which we have used to represent physical quantities. Let us compare these three systems and find out what were the units. For length, in SI system presently we have got meter, in CGS we had centimeter, and in FPS we had foot. Similarly, for mass, current SI system uses kg, CGS system uses gram, and imperial system uses pound. Okay. For time, you can make a note here that it was commonly second throughout all the systems of units. For time, it was seconds represented by S. Going ahead, for temperature, the current scale is Kelvin. This is an absolute scale. Whereas you had relative scales in Celsius and Fahrenheit in CGS and FPS system. We will learn more about what is absolute scale, what is relative scale when we come to thermodynamics. Okay. Moving on, I would like to give you one instance or example which will make you understand what is the importance of standardization of units. What is the importance of having a standard unit in any work? Okay, across nations, we said that it was internationally accepted. When we defined units, we said that it was internationally accepted. Let us take the example of the Mars Climate Orbiter, okay, which was around in September 1999. It was a very important project of NASA. It had almost taken 10 months to go into the orbit of Mars. When all the scientists were preparing to celebrate the success of the mission, okay, the ground reality turned out to be completely different because someone had failed to use the right units. It blasted into pieces as soon as it reached the surfaces of Mars. What happened there? It was not some big error. It was a very, very small mistake. What was that mistake? People sitting at the United States were using a different unit. People sitting at the United Kingdom or Britain were using a different unit. What was the time? I am not talking about pre-independence period or something like that. It was in 1999. Science had evolved so much. We had all accepted SI units to be internationally accepted. Okay, but still we failed. What was the loss that was incurred? The loss incurred was 125 million USD. This was almost the budget of entire Indian Railways at that point of time. That was the huge amount of loss that was faced. Why? Because people did not use a standard unit. Someone was using the imperial scale of foot and inch, whereas someone else was using the SI unit of meter and millimeter. This was the only problem that we had faced. Okay, so can you make out, just because of two different teams of people employing two different sets of unit, what was the loss? The loss at that point of time was $125 million. Is that understandable? Okay. So that is the importance of adopting to whatever units that is required. Finally, there are certain guidelines with which you have to use these units as well as symbols. Suppose I am writing second as the symbol. The time 11 seconds was employed. It has to be as small as. I cannot write it as seconds like this. No, this is wrong. This is the right one. I cannot write it as 11 seconds, capital S. This is once again wrong. Okay, so what are the rules? Let us check. Symbols for units are written in lowercase, small letters, starting with small letters. I cannot use a capital letter. I cannot abbreviate it as I like it. Okay, the symbols are provided by SI system and I have to just follow it. The unit names are never capitalized. Okay, it is not capitalized. I cannot write a capital S. I cannot write a capital M for meter. I cannot write a capital K for kg. Then where can I use a capital letter? Capital letters can be used if the symbol for a unit is derived from a proper name of a scientist. If you have taken the symbol from the name of a scientist, then I can use it. For Kelvin, I use a capital K. For degree Celsius, I use a capital C. For degree Fahrenheit, I use a capital F. For ampere in electric current, I use a capital A. Okay? So if the symbol is derived from the name of a, I can use capital letters. Otherwise, I have to use the lowercase. And symbols for units do not contain any punctual marks. You need not put an apostrophe S, comma, full stop, nothing like that. Okay? Units will not contain any punctual marks and will remain unaltered in the plural form. What do you understand by plural form? I cannot write 11 seconds as 11 second followed by one more S. No, that is wrong. Or say for example, the dimension of the plot is 110 meters. So I cannot write it as MTS or MS. These are all wrong. I have to just write it as 110 meter. There is no plural. If you write a plural as S, people will understand that it is for second, not for the plural form. Okay? So in today's class, we have tried to understand the basics of measurement. We tried to define measurement. What are physical quantities? What are fundamental and derived quantities? What are supplementary quantities? What are the units for these? The physical quantities, the primary units, the derived units, the supplementary units, the three systems of measurements in SI, CGS as well as FPS units. We made a comparison of those and then the guidelines which we have to use for using the symbols and the units. Thank you.